Now it's true most home lawns are only going to be injecting nitrogen or just basic fertilizer. But there is a chance on a home lawn you might inject an insecticide. And you know, if you just drank a little nitrogen, it's probably not going to hurt you too much. But if you drank a little insecticide, it might make you real sick. So kind of somewhat would matter on what you're injecting in there as to what your thought process is too. But it also must be legal. And so that device is a legal device. Now the ultimate is to have a double check. Again, flow is coming this direction. It's going through two check valves. But it's also going through, between the two check valves, there's also an air relief, an air gap between the two check valves with a poppet, so that if you go to zero pressure and go into a vacuum mode, this thing pops open and it vents to air. So if something does get by the second check valve, it comes right out and spills out the bottom. So it literally breaks the path of the flow totally. As long as it's pressurized from the upstream side, it's going to push down and keep the flap in check in the middle chamber. But as soon as you lose upstream pressure, that flap closes back the other way, and anything that would come from the downstream side is going to vent right out the bottom of the valve. Now that is fail-proof, unless somebody goes in and sabotages it.
What's your pressure loss on these things?
A lot. Yes. The question is pressure loss. You know, how much is the pressure loss? Generally speaking, you're going to lose around 2 to 4 psi through your backflow preventer. On turf, that we just look at, give it 3 psi loss on any given one, and it would depend on, again, the size and the flow. You know, this is a little 3/4, but if I only ran 5 gallons a minute through a 3/4 inch double check, I might only lose a pound or pound and a half. I'd have to look it up. Every one of these devices does have its flow rating, and the friction loss is dependent upon the flow. I crank the flow up to 15 gallons a minute through this, I might lose 7 or 8 psi through it. So flow is, you know, then I'd have to go to a bigger size. I'd have to go to a 1 inch to drop that pressure loss back down again. Sure. But this is a double check with a low pressure relief in the middle of it. And these little ports here are for testing it. So we can actually go in, and in fact that's a pretty good job. That's a career for a lot of people. They simply go around and test backflow devices for cities, counties. It's a lot of areas. That's something that they monitor, and they will check them every 6 months or a year to verify that they're working correctly. And what you're doing is you're monitoring the pressures at the different ports, and you can turn the valve on and off at these control handles and monitor what the pressures are happening between pairs of the ports to see if it's functioning the way it's supposed to find out if there's leaks in it and that the valves are actually activating.
What is this called?
This is called a pressure reducing double check valve. Pressure reducing double check valve. And that's the ultimate right there. It's pretty heavy. And of course, every one of these costs that much more money than the next. The little atmospheric vacuum breaker is a very inexpensive little device. Just on a 1 inch scale, we can kind of give you a value on the 1 inch scale. It's about 12 bucks. We go to the pressure vacuum breaker, we're up to 50 bucks. We go to the standard double check, we're up to about 75 bucks. We go to the pressure reducing double check, we're on 1 inch size, we're up there to the $140, $150 range. Just on 1 inch size. So you can see what's, you know, people want to get away with the cheapest they can, but then you ask yourself the question, would I drink the water? Am I sure it's going to be safe enough for me to drink the water? And I tell you what, that'll make you want to buy that pressure-reducing double check in a hurry if you're pushing some really toxic chemicals through your system.